Well, today we're going to get into a bit more of calculus terminology. We're going to talk about increasing and decreasing functions. We're going to talk about maximum and minimum values. All are terms you're going to find readily in calculus. So let's get started with section 3 in chapter 2. And, oh yes, try that again. All right, so I've got a function graph for you. It's x squared minus 2x minus 3. Right away, you should recognize it as a parabola that opens up because it's got a highest power is 2, the degree is 2, and notice the x squared term is positive. So you know that as soon as you see that it's a parabola opening up. I've sketched it over here, okay? Find f of 1, you can look and say, where does 1 go? 1 goes to -4, okay? Or you can put 1 in here. 1 minus 2 is -1, -1 and -3 is, it's -4. So it does, you can find it two different ways. Get -4 from the graph, or get -4 by putting 1 in there. Find an x value so that f of x is equal to -3. So if the function x squared minus 2x minus 3 is to be equal to -3. Okay? Solve this equation for x. Get everything on one side, add 3. I get x squared minus 2x equals 0. Take out an x. Set each part equal to 0, and don't I get 0 and 2? Okay? And you could have also gotten that by saying, find an x so that the y value is -3. Here are the y values. -3 goes across this way. What are the x values that come down to -3? And it's 0 comes down to that, and 2 comes down. All right, so it's 0 and 2. Find x so that f of x is 5. So I can just replace this with a 5 right here. Get everything on one side. X squared minus 2x minus 8 is 0. Wouldn't it be nice if it would factor? Factors of 8 that subtract to give you 2. 4 and 2, yeah. X, 4, 2. To get a -8, one of these has to be positive, one negative. So go to this sign, it goes to the bigger one. And would you agree the inners are bigger than the outers? So negative, positive. Set each one equal to 0, you get 4 or -2. How else could you have done that? Where does the functional value, where is it? 5. Okay, here's the y value of 5. And where do I find x values that go up to 5? -2 goes up to 5, and 4 goes up to 5. So you can do it from the picture, or you can solve it. For a domain of -1 to 3, find the range. All right? From -1 to 3, find the range. Here's x equal to -1. Here's x equal to 3. Okay? In between -1 and 3, what are the y values? Well, in between -1 and 3, the y values are all down here from -4 to 0. So if the domain is -1 to 3, the range would be -4 to 0. Because the x values here from -1 to 3 go down to these y values, which are -4 to 0. Remember, you look sideways. Okay? Notice that f of 3 is bigger than f of 2. F of 3 is here. F of 2 is here. You see, this is bigger than that, which means the function from here to here is going up. So the function is increasing from 2 to 3. How about f of -1 is smaller than f of -2? Here's f of -1 right there. It's that 0 value. Here's f of -2. This value is smaller than that one. So from -2 to -1, the curve is going down. You see how I'm saying that? I'm saying from -2 to -1, the x's, the curve goes down. Over here from 2 to 3, the curve went up. Okay? Definition for increasing and decreasing function. F is increasing on an interval I if for any f of x bigger than f of w and x is bigger than w. I better draw it. Let's draw it. We have an interval I, okay, so let's say from here to here, this is interval I, and we know the function is going up, okay? Then if x is bigger than w, so here would be x, here is w, then doesn't f of x up here have to be bigger than f of w? Yeah? Okay, then the function's increasing. It's going to be decreasing if x is bigger than w, but f of x would have to be, if it's decreasing, x is still bigger than w. If it's decreasing, wouldn't f of x have to be smaller, less than f of w, okay? Increasing, decreasing functions, something you do in calculus all the time. Let's talk about maximum and minimum values. F of A is a local maximum if f of A is greater than or equal to f of x for all x's near A. All right, so take a look at this graph. Suppose right here, it says 2, if you can see it, but suppose that's an x value of A. Then f of A would be a local max if the functional value of A up here is bigger than or equal to functional values on either side. X is near to A on either side. There must be an either side. If the function stops there, it can't be a local max. It's got to have functional values on either side. Everybody catch that? Okay? The other strange thing is f of x is greater than or equal to. So in essence, it could allow for a little bit of a flat spot. If you have a flat top right here, then you'd have a whole lot of little points there that could be local maximums. All right? It allows for a flat top. Here's the other part, a local minimum. F of A, let's go over to this one now. This would be a minimum value, local minimum, if A would be right here on the x-axis. F of A, the functional value, has to be below, smaller than functional values on either side. Now, one thing to get straightened out right away, okay? A local max does not have to be the absolute biggest value of the function. Like right here, see how big that is? It looks like it's up about 1 unit, okay? But over here, look at all those y values. They're even bigger than that. All right, so a local max is just bigger in a certain neighborhood, which is a real good calculus term. Right here, this is bigger in this neighborhood. This value right down here is smaller just in this neighborhood because out here, they're even smaller than that. Okay? Local maxes and local mins. One other thing about a local min, remember there have to be y values on either side. Okay, if the curve would end right there, it's not a local min. All right, which is larger, f of 0 or f of 2? 0 goes to 1, 2 goes to 1, neither one. They're the same. Give me increasing and decreasing intervals. Let's assume this goes on forever and goes on forever. Okay, increasing and decreasing intervals. You do it on the x-axis. So, from negative infinity to this thing is, see how it's coming down? It's coming down, it's coming down, it's coming down. It's looking like that is roughly like at a half. From negative infinity to a half, the curve is decreasing. Okay? Then from a half, it starts increasing at a half. It increases till you get over to x equal to 2. So from a half to 2, it's increasing. And then from 2 to positive infinity, it is decreasing again. Are you with me? Can you do that? And make sure you do it on the x-axis, okay? Find the x value of a local max or min, all right? To me, this min looks like it's roughly at about a half, or maybe 3/4 would be a little bit better than a half, okay? I think I'm going to change that. This should probably be 3/4, all right? So we're going to put 3/4 and 3/4. All right. So find an x value of a local max or min. 3/4 would give you the min. 2 right here. 2 would give you the max. Find the domain when f of x is bigger than 2. Well, the only place where the function, the value gets here is 1, 2. When it's bigger than 2. What x values go to this part? Well, it looks like the x value of maybe a quarter, negative a quarter and down, would put you at y values bigger than 2. So if we want bigger than 2, I'm going to say you can't use 2. Okay, so I'm going to say from negative infinity up to a quarter, parenthesis, because we don't want to use 2, is the domain when f of x is bigger than 2. Now, find the domain of the whole thing. Find the domain of the whole thing. Are there any x values that don't have a place to go? Out here they go down, in here they go up, here they go down, here they go up. All real numbers. Ugh. Why does this computer keep doing that? Okay. Try it again. All right. I wanted to give you a function that has a cusp. A cusp is a point. Okay. Perfect calculus word, cusp. All right. What is g of 0? If this is a function g of x, g of 0, 0, this is 2.5, 5, 7.5, 10, 12.5, 15, 17.5. So g of 0 looks like it goes to, this was 7.5, looks like it goes to about 8. Okay, g of 1. G of 1 looks like it may be at 7.5. Okay, g of 2, the functional value of 2 is 0. All right, how about increasing and decreasing intervals? Okay, so we're doing it on the x-axis again. We're going to start at negative infinity. So negative infinity, it's going down, 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 boom, to 2. So from negative infinity to 2, from negative infinity to 2 on the x-axis, the curve is coming down, assuming it goes on and on in both directions. All right? And then from 2 to positive infinity, would you agree that the curve is going up? Okay? Maximum and minimum points. We have no maxes. The curve keeps going up forever and ever and ever. Okay? How about mins? Okay? How about mins? Now, I'm assuming right in here it's constantly going down. It looks like it's almost flat, but I'm assuming it's constantly going down. Okay? Minimum point, 2, 0 would be the minimum point. Find the maximum and minimum values. There is no maximum value. Minimum value is just 0. How about domain and range? Are there any x's that don't have a place to go? These all go up. Those all go up. 2 stays right where it is. All real numbers would be the domain. How about the range? This is where you look sideways. What y values are being used? Only the y values greater than or equal to 0. So the range would be real numbers bigger than or equal to 0. How about another one? I want to do a lot of these to get you practiced up here. Find h of 1. This is the function h of x, or h of v, pardon me. 1 goes to 3. How about 2? 2 looks like it goes to -1. How about 7? 7 goes to 0, right? Find the domain and range. Okay, now this one stops here and stops there. All right? So the only x values that have a place to go, they start at 1, goes up to there, and 10 goes up to there. So the domain would be from, domain is 1 to 10. How about the range? This is where you look sideways. Look sideways. The first y value I see here is at -2. Then there's all kinds of y values used here until it gets up to here, and that is 6, 7. So from -2 up to 7 is the range. Yeah? Find the v values where h of v is 3. Okay, so here's 1, 2, 3. Okay, now find the v's where h of v is 3. So if I'm up 3 here, 1 goes to 3. And whatever that is right there, it's for those of you viewing this online, it's probably pretty tricky to see, but that's a little less than 9. I would say like 8.7, 8.8 will take you up to 3. Okay? Find the v's. Remember, the v is the x value, where the functional value is smaller than 0. If the y values are less than 0, they're below this line, the x-axis. So what are the v's that go down? Well, the first v looks like about 1.5. Will put me right on the x-axis. And 5, 6, 7 puts me right on the x-axis. So where the y values go down, I'm going to say parentheses 1.5, because 1.5 puts me dead on it. I don't want to be dead on it. I want to be below 0. Okay? Up to 7, and I want to, 7 puts me right on the x-axis, so it'd be from 1.5 up to 7. Local max and min points. Okay, I see a minimum right here at 3, 2. Over 3 down 2 is a minimum. This is not a local max. This is not a local max because there are not points on either side. To the right, sure, this is bigger than those, but there'd have to be something over here on the left, and there's nothing. Same thing for that one. Neither one of those are local maximums. This is kind of fun. Red, blue, and green. Okay. Let's check this out. Find f of -3. Can everybody see that all right? Let me just double check. Yeah, it's getting small, but hopefully you can all see that. Find f of -3. The function takes -3 to 0. Okay? F of 0. The function takes 0 up to 4. F of 2. F of 2 is undefined. Whoa. There's no value for f of 2. F of -5. Where does -5 go? Stays at 0. Y value of 0. Find the domain and range. Okay, now notice this does not go on forever. It starts here, it stops here, starts there again, and stops over at 5. So this is going to be a little tricky. The domain. Let's talk about the domain. So from -5 up to 1, the x values are being used. Watch how I'm going to write this. -5 to 1. Messed up. -5 to 1 bracket. Starts here, stops there. From -5 to 1, those are used. Now, it starts at 2 and goes to 5, but 2 is a parenthesis because 2 is not included. 5 is included. Are you with me? Okay. How about the range? This is where we look sideways. Down here, there's nothing. Whoa, starting at -2, we hit a y value. Coming up across, we hit lots of y values in here, the whole way up to 4. So from -2 to 4, so the range is -2 to 4 brackets, because both -2 and 4 are used on the y-axis. Find x's where f of x is 3. Here's y value of 3. -1 goes up to 3, and +1 goes to 3. So -1 and +1. Find x's where f of x is 0. Where is the y value 0? -5 to -2, in there. Okay? Bracket, -5, bracket, -2, it's equal to 0. And also, over there at 3, it is equal to 0. Think about that a second. How about increasing, decreasing intervals? Okay? From -5 to -2, it's not doing anything. From -2, right here, starting at -2 to 0, you see it's going up? So, from -2 to 0, it's going up. From 0 to 1, you see how it's going down? So 0 to 1 going down, and then, excuse me, from 2 parenthesis to 5, it's going down. So from 2 parenthesis to 5 bracket, it's still going down. Local max min values, not the points, just the values. Okay? Now, this one's going to be a little tricky. -2, 0. -2, 0, right there. That is smaller than or equal to points on either side. That is a local minimum. So the value right there is 0. All I want is the value. So 0 right here is a local minimum. This one, 4, the value. 4 is a local max because it's bigger than or equal to values on either side. This one you can't use because there's nothing right in here on this side. And this one you can't use because there's nothing to the left. Okay? And this one right here you can't use as a minimum because there's nothing to the right. Got it? Technically, in a way, from -5, I'm going to write this down, -5 to 2, bracket. All of these x values here would produce minimums. But because I only ask you for the value, the minimum value here is 0. I took care of that whenever we talked about this corner point. I said 0. But technically, all of those x's produce minimums. So you have millions and millions of minimums there, which is very strange. Homework. Got some good ones to practice on. Especially, don't miss the extra problem. That's a great problem. You should be able to sketch most of that without plotting any points whatsoever.